This is a very interesting ECG. What you can try to see is you can try to zoom in and find out what is the problem in this ECG. So both these ECGs are of the same patient, and when we see, what we can really easily notice is the first that thing that we can notice is QRS is white. So normally the QRS, so this to this, so this is R and this is S. So this is all S wave only. Normally, the normal QRS should be less than 100 milliseconds, means 2 and 5 small boxes, 2.5 small box. What we can see in here is very, very clear. There is one box, two box, three box, and half box. So it is a 3.5 small box. One small box is equal to 40 milliseconds. So more than 120 milliseconds is what we call it as wide QRS complex. And when it is between 100 to 120 milliseconds, we call it as borderline wide QRS complex. So this is definitely for sure is wide QRS complex. Second thing which we can see is there is subtle but a very well. This is T wave and it looks dented and it looks sharp. So the T is large and it is very much symmetrical, dented and peaky. So the signs of hyperkalemia, whenever the potassium is high, the signs of hyperkalemia is what we get is a tall, dented, symmetrical, peaking T wave. Symmetrical and peaking T wave. So it has to be symmetrical. Symmetrical in the sense we can compare this with the T wave of this. So now here the T wave is not symmetrical. It's not symmetrical means the T is starting from here and it is ending here. So it is more of like this. So if we draw down a perpendicular, this is less distance and this is more distance. So this is called asymmetric T wave. So we can see in here also that if we draw down a perpendicular, this is a less distance and this is a more distance. But in here, this is exactly the. So if you draw down a perpendicular, this and this distance are almost the same. So this we call it as a symmetric T wave. So QRS is white. We can see the QRS it is showing is 189 milliseconds because these are all wide QRS complexes. This is all wide QRS complex. You can very easily see there is 1, 2, 3, 4, and 4.5 small boxes. So one small box is equal to 40 milliseconds. So 4.5 is around 160 to 180 milliseconds. So the QRS is definitely and definitely wider. The next thing which we can see in here is the P wave. See, the P wave appears very, very small. So in here, though we can see the QRS wave, we can see the QRS wave, but the P wave is not there. If it is very difficult to find P wave here. So this is a P wave and QRS is pretty far from that. So what we can call it as the P and R distance, the distance from P to R should be one totally 5 small boxes. But in here it is 1, 2, 3, 4, 5, and 6. So there are around 6 small boxes, means the PR distance is prolonged. So whenever we call it as PR distance is prolonged, it is first degree heart block. So there is no drop of any QRS and PR is prolonged. That is first degree heart block. It is very well evident here as well. So this is the P wave. So PR distance is first, second, third, fourth, 5, and 6th. So there are 6 small boxes. So it is around 240 milliseconds. So the PR is prolonged there is no QRS drop, but PR is prolonged, so that is first degree heart block. The size of the P wave also appears very, very, very small. So we can compare this here that if we can see in here, this is starting of P1, 2, 3, 4, and 5. So this is slightly corrected. Or if you see in here, 1, 2, 3, 4, and 5. So here, this is very well visible. That is 1, 2, 3, 4, 5. So here the PR is exactly 5 small square. So the PR prolongation or the first degree block is corrected. So compare the QRS complexes also. Here it is very wide, here it is narrow. Here the QRS complex is 100 milliseconds. So the wide QRS complex is corrected, the tall T is corrected, and first degree heart block is corrected. So the patient had potassium of 7.7. So this is a very typical ECG of hyperkalemia causing these changes. I have earlier also told so many times, normally potassium should be between 3.5 to 5.5. When potassium is between 6 to 7, what we get is tall, dented, symmetrical, peaking T wave. So these are the findings of hyperkalemia when potassium is between 6 to 7. When potassium is between 7 to 8, we very commonly get wide QRS complex and loss of P wave and first degree or heart blocks we can get. When the patient has potassium of 8 to 10, patient can anytime have VT, VFib or oscillotone. And when potassium is more than 9, patient can very commonly get sine wave pattern where on ECG leads we'll only see this pattern. There will not be any QRS P, so this is called sine wave pattern. And when the potassium is above 8, we can very commonly tend to 7. When the potassium is more than 7, patient tend to have any heart blocks like first degree or second degree heart block as well, or patient can also have complete heart block. So this was all about hyperkalemia. Thank you for the watch.